when you are building, you have to rope in your structural engineers so that you be safe at all costs. Your life is important.
Okay.
And then 2, when it comes to economic, so you have to be very economical so that you not spend more for less. Somebody will come, I have one story. I decided to go up to 3 stories. So engineer, how can you help me in doing this? Because it wasn't intended for it.
All right, Sally, welcome to the ABC show.
Thank you.
So you would say that a structural engineer basically looks at what does a structural engineer look at? If you take a building project, what is the role of the structural engineer on that building project?
Okay, so the structural engineer is to take care of the building, the structure of the building.
Okay.
When you talk of structure, it's like a skeleton, the core, the skeleton. As human beings, if we don't have skeleton in us, we can't stand.
Okay.
Yeah, so that's a skeleton of the main building. Yeah, so the architecture comes in, and then the structural engineer comes in to fill in the skeletal system of the building.
Okay.
So with that, you can know your building will be able to stand in the aspect of safety, economy, that's economical, based on cost. And it has to be sustainable.
Okay.
Serviceability too is part of it.
Okay.
Yes, so that's how we come in and we help in structural designing and then structural implementation of what we do.
How did you get into the space?
Okay, so I loved architecture when I was young. Yeah, so I told myself I wanted to be an architecture lawyer. That's what I told myself. But eventually, Ghana, we don't have architecture lawyer. So I did a little bit of architecture. So we passed through the system of ATTC,
Okay.
but a subsidiary of ATTC, that's Modern School of Architectural Draftsmanship.
Okay.
That's within, yeah. And then when we finished that side, we roped ourselves into KNUST to do proficiency in architecture. And then from there, I saw the concept of architecture is not all, so I have to move on. Yeah, so we moved on to Accra Polytechnic.
Okay.
to further our course in, to switch
Okay.
to civil engineering.
All right.
And then we also moved from there to help ourselves in KNUST
Right.
for the continuation. So that's how we got ourselves roped in. But notwithstanding that, I got some mentorship as well.
Okay.
Yes, or my bosses were there to push me into civil engineering because they were all civil engineers.
Okay.
Yes.
All right, I get it. So why do I need a structural engineer on if I have a building project coming up? Why would I need a structural engineer?
So every building is supposed to be safe for whoever is living in their habitat. Not only habitat, also, if you look at roads also, it has to be safe that people can ply the road without any problem. And then on other aspects as well, bridges and stuff, it has to be safe. That's the number one aspect. Okay. So when you are building, you have to rope in your structural engineers so that you be safe at all costs. Your life is important.
Okay.
And then 2, when it comes to economic, so you have to be very economical so that you not spend more for less. So eventually, maybe knowing the strength of material, you know which kind of material you are going to use and what not to use.
Okay.
Yes, so that you know overburden your building by the design. Yes, and then also sustainability. You have to be, so how the material is sustainable when it comes to the condition we have in Ghana. When the sun shines, the rain falls, when we have thunder, we have earthquake and all those stuff, if it's going to stand within time. And also, you have to do it in a way that maintenance should be a culture as well. So the civil engineer will be able to take you through all those procedures so that your building will stand a test of time.
Okay.
Yes. So you need a structural engineer at the conception of your building. After the architect have brought his design, the structural engineer have to come in and then do his calculation. Yes, but by the help of the geotech engineer.
Okay.
That's with the soil, the capacity of the soil, how the ground is able to take the load that the building is coming on is going to take. Okay. So the axial loads are the loads that we get from the building. So basically a vertical load that is coming onto the ground. Yeah, so we have to know the capacity that the ground can carry, then we can give it to it.
Okay.
Yes.
So I mean, you mentioned cost, and that for me is of interest because now building materials are going up.
Yes.
Most of the things because we import them. How do you come in to save costs? Is it the kind of materials I need? Do I use the iron rods I use, the kind of blocks I use, the kind of cement, all these things? How do you come in to help anybody who is looking at taking up a building project, starting a building project, reduce costs?
Okay, so if you watch our system in Ghana and our weather, so let's look at the system first. In the system, we have codes that we use in doing our design. We call them the building codes. At first, we were taken from the Britain. Now, Ghana have developed their own codes that we use, but it's still basically from the
British.
The British, yes. When I'm taking you back, when the engineering started in Ghana, the Americans concept two were in. That's where we use the Imperial, and then now Britain concept two came in. That's where we are using the BS. So they are all codes that we use in designing. Okay. So all codes are specific to what you should do and what not to do. Okay. And we have factor of safety in everything we do, even with the design. Okay. Yes. So when we simulate the design on our PCs and all our calculations, you should be able to stand the code. So if the code says A, you don't have to make it B because you think it's right. Yes. So basically, our system gives us more advantage on doing the concrete. Okay. That's why we normally use the solid concrete thing on the ground, and then the columns comes in, the iron rods comes in, and then the sandstone, the mixture, then we use. But now people are modernizing their space. Yes. So at a point, people start doing bricks and doing hydroform. And they are all systems that we can use. But I think the cheaper way to go is by our blocks and our concrete. So that's the cheaper way to go. Yes. So people even introduced the concept of doing wooden partitions and also doing hydroform partitions. We can do them. But because the concept is there, everybody wants to move by the old way of doing things. So we stick by it. Okay. Yeah. So basically, that's what I'll say about that. But the sandstone, cement, and then iron rods, that I've kept that going for about decades now.
Right. Yeah, so you've given a background of all these things, but I'm still looking at, in terms of cost, are you able to reduce my cost by, say, 10%, 15% if I engage you at the beginning, rather than wait till I hit a problem before I come in? And if you are going to help me do that, what are you looking at? Are you going to inform which kind of blocks I use as I go up, what kind of roof I do so that I save money? I mean, in Ghana, the kinds of roof we have don't fit our weather. I don't think we even use them for the purpose for which they are being made, where we copy them from. How do you inform all these things so that if I'm looking at cutting down costs, or making sure that whatever money I have can fit the project, how do you help me in doing this from foundation to the point where I can actually move it?
Okay, so building is very expensive. Yeah, it's not a child play. It's very, very expensive. That's why when we come in, we try to show you what to do. The normal layman will not do calculations and you just throw in the iron rods, then throw in the sand, the stone, without mixing it very well. So when they do that, you rather the cost go against you, the client. Because when you know that maybe one cement is supposed to do this number of sand, you know that you are getting value for money. But they will come and then say, oh, this one, we have to put too much, we have to put plenty cement in it so that it will stand the test of, but per calculation, maybe you just need maybe a half bag of cement to do that. So it saves you the client a lot of cost. Maybe the iron rods, the beam is supposed to carry just 2 at each cost, at each section. But you'll say, oh no, because this spans too much, let's put in 6. You understand? So that 6 is a whole cost of on it on. And then maybe the slab. The slab also, you need to just do a 10 mm, so 4 inches slab. But because they think we always do it, so let's do it how we normally know how to do it. Yeah, so with all this, when the structural engineer comes in, he's able to tell you what to do at what and what not to do. So with that, we are saving cost. You are saving cost within that aspect. Yeah.
So you come in, you're able to tell me that, okay, as I go higher, I use maybe hollow blocks.
Okay, all right.
Or I use the columns should be here, shouldn't be there. And sometimes when you usually go into a conference where there are so many columns, you can't actually have, so you come in and you can advise some of these things.
Yeah.
All right.
Yeah. So as you were talking about the hollow blocks, so hollow blocks have been a concept that, so as the building is going up, it's supposed to be lighter.
Okay.
Yes, that's why a lot of works have been done on flooring. People are bringing more floors into the system now, that's to make the building a little bit lighter. So you do your walls with the hollow blocks as you are going up. And remember, blocks are not structural.
Okay.
Yes, they are partitions, they are cladding.
Okay.
So it shouldn't be a concept of the block is supposed to carry the building.
Okay.
So yes,
the columns are
the columns, the beams, they are the ones carrying the building. So you can use any component for your wall, so far as it's able to stand what you need. Your security is assured.
Okay.
Your weather, penetrations and stuff is assured.
Okay.
Even wood. Yes. So you can even use them for your, but it's your safety is number one priority. That's why we normally want to use the blocks when somebody is trying to break in. They find it a little bit difficult. That's why we are using the blocks. And then on the flooring too, the Trasaco Fast Floor came in. I'm not doing an advert for them. Yeah, they came in to reduce weight on the building by bringing in their fast floors, and also now there are composite floors that are in. It's in the system long time, but now Ghana people are introducing it. The composite floor comes with the base as a metal. Then you pour your concrete on it. You don't need iron rods and anything, and it's thin. Yeah, it's there for you.
So the base is a metal.
Yeah.
Then you pour concrete.
They pour concrete on it, so you call it a composite floor.
What kind of metal?
So there's a designed metal for that.
Okay.
So that's what you use for the flooring.
You also mentioned the Trasaco
fast floor.
Yeah. How does that look like?
Okay. So they are block-like system, and with a tension beam. So you can see the beam are very lighter and smaller, but they are stretched in a way that they can be able to resist. Yeah, they can be able to resist load that are coming on.
Okay.
With our normal iron rods we have, they are not stretched. They are normal rods.
Okay.
But this one, they are stretched to a point that they can't easily bend.
Okay.
Yeah. So with that, they put them at vantage points, and then they put in their blocks. So when they arrange their blocks, that will form the platform. Then you can pour a little bit of concrete on it, and you are gone.
Oh, okay.
Yeah.
Now you also talk about the structure itself and the structural integrity. What do you mean by structural integrity? When I come in and you say, okay, we need to ensure the integrity of the structure, what are you looking at?
Okay, so integrity is the strength that the structure has. The integrity is the strength that the structure has.
Okay.
So so we normally check our integrity on the beams and the columns.
Okay.
And then sometimes the floor, that's the suspended floor. That's where we check the integrity, because they are the ones carrying the building. Yes, so if they are not able to fit to standard, which means they don't have the integrity for a particular type of system.
Okay.
Yeah, so somebody will come, I have one story. I decided to go up to 3 stories. So engineer, how can you help me? in doing this because it wasn't intended for it. Yes. So when we come in, sometimes our artisans are able to do something, they over design. So when we come in, we check our integrities on the columns beams. Then we'll see whether it will be able to stand the load coming on.
Okay.
If it's able to stand, our calculations will tell us yes. If not, then no.
Okay.
And we can also help in fixing. We call something jacketing, and jacketing. We can jacket and then we can go up.
Okay.
Yeah, so we can also work on that aspect.
When you say jacketing, what is that?
So jacketing is a form of reintroducing iron rods.
Okay.
To be able to sustain the new loads coming on.
Okay.
Yeah. Some iron rod, when you go, some of the buildings have iron rods in it, but when you check the integrity, it doesn't fit to standard.
Okay.
And the person still wants to go up. Maybe that's the only land the person has, and he wants to go up. So you have to jacket. Even at a point, you can even jacket the whole building.
Okay.
That's the beam, the column, the floor, and even the walls as well.
Okay.
So that you can go to the extent at which you want to go up. Yeah.
All right. Whilst we were having a conversation earlier, you mentioned that you feel that in Ghana we waste a lot of space.
Yes, sure.
Because when you watch outside, you realize how buildings really go high. There are a lot of skyscrapers, high-rise buildings. A few are coming up in Accra Central. If you look, you see a lot of high-rise buildings coming up. How do we save space? In ensuring that whilst you work with a structural engineer, how do you ensure that you are working to save space and building sustainably so that the people who come after us also have some land left for them?
You see, in Ghana, is how the government don't manage lands. Yeah. So lands are managed by individuals. So that's the cost of whole waves of people not trying to go up. Because you buy your land and you want to do whatever you want to do on it. But for me, I think that we can manage our land very well so that within, let's say, a smaller space, we can have a lot of people coming out from that building as going to work in the morning and coming back. So that's the concept that I always adapt to. I want Ghana, our thinking to change to that concept. Where the location you're going to sleep, what is the size? Well, you're just going to sleep in a small confines, but you're going to have a very big, vast area that you're not using for anything. So I think when the government is able to talk to manage land space use, I think the government should come in and tell us something. Then they should get the disassemblies to show us how to misuse the land, because we have planners at the disassembly. Yeah. The planners can tell you what to do with your land and what not to do. And also, it's, how do you call it? It's already in books where you have to position your land. If it's a factory, you have to put it there. If it's not, if it's a church, you have to put it there. So they can help you to do that. But for me, I think that when the government comes in and enforce that we shouldn't misuse the land, we should have type of buildings and where they are supposed to be placed. I think we can go upper and upper and upper than to just build bigger buildings and you don't have use for it.
All right. So beyond the government coming in as an individual who wants to build, and I think that I maybe have a piece of land in a location where I would want my kids to take, probably also stay. How do you help with such structures that I can build, say, probably a ground and a first floor when my kids grow up, they can also decide to continue? How do you come into to design and help us achieve that?
Okay, so with that, I think, I don't know if an individual or maybe the government is supposed to do that to tell us the concept we should use for our building. If not, so we'll still do our big houses and then we stay by it. But we can take in that aspect of it where we can, design our buildings down. Then our children can come and then build on and on and on till we elapse our axial loads.
Okay.
Yes, so it's a laudable idea from the other companies, countries doing it. And then I think Ghana should also, embrace that at that point. Yeah, so that we'll not misuse our spaces. Because now Accra is getting choked. We are moving towards Kaswa and beyond. And this side is moving towards Dodoa and back. And then the top two is moving towards. So you can see we are moving. And at a point, maybe we'll not even have lands to build. Yes. So when we have the concept of building high rises, I think it should be okay for us to be able to sustain our lands. Yeah.
I mean, you talk about Accra being choked.
Yes.
Then Accra is being choked, and I mean, there's a road construction going on where we are, and number of buildings that have been either broken into or some have been cleared completely. So if there's a building in the middle of the road and a part of it has been taken off structurally, what should be done? Should I just go get a mason and say, Charlie, now there was a wall here, just seal it and let me go in and use it, or there's something that I should do? I should bring in a structural engineer.
Okay, so road construction, so roads have been earmarked for transportation and easy movements, not only for vehicles or anything, but human beings as well. So at a point where they earmark the road for easy movement and people will come and build on the road corridor, it's a problem in Ghana. Yes, so for me, I think the District Assembly have to come in and do their work very proactively to tell people building in waterways and then road corridors to be careful and not to give them permits to do that. But when there is a genuine concern of land bought by the chiefs and then the permit have been given, then with that one, if you are looking at the compensation method, we can give you compensation and then move from there. You move from there totally, yeah. And then also, if you think you can salvage your land, when you are not having any compensation, you can salvage it in a way by introducing the structural engineer to check the integrity of the building. If you can it's still habitable, because your safety is your priority. Yeah.
So a part of the building has gone off and I have nowhere to go. If I bring you in, you come look at it. Do we redesign? See what do we introduce? It depends on what factors we'll consider. Would you consider to say, okay, just a part of the building is off, so you can redo it or fix a few things and stay in?
Yeah, so a part of building is off. We need to check, because load dissipates within the building at all points. Okay. So when part of it is gone, is it where there is load, where there is no load and stuff? We have to check all. So the integrity is able to tell us what to do and what not to do. But when we check and it's able to sustain itself, then we can come in and redesign. Okay. Yes, we can redesign the building in that aspect so that the person can re-inhabit the building again. Yes, it's possible.
All right.
Yes.
At what point do I need to bring in a structural engineer? Is it when I get the land and have the idea to go build my house, or when I get a design from the architect? Do I engage the person personally, or the architect will usually engage you and I get charged or billed for that, or I have to do that separately?
Okay, so the system in Ghana normally does not force anybody to bring the structure or architects on. The only thing that will disturb you is when you are going to take your permitting. That's where they will ask you if you've engaged the architect, because the architect have to have a stamp. The structural engineer also have to have a stamp to certify that the building regulations have been followed. Okay. Yes. So with that concept, I think when you see your land and you know what you want to use it for, you have to rope in the architecture and then the structural engineer. You can take it as one unit, or you can take it as a separate unit. Okay. The structural engineer can do the building for you by the design and the spatial planning and stuff. Then the structural engineer will come in. But that's in the inception. Yes, the land, you can buy any land at wherever you want, whilst it's legal. Okay. Yes. So it depends on what you want to do on the land. When you say you want to build maybe a single room, And architects can do, because architects also have the know-how of how a structure should stand. The architect can do a single room for you. You take your permits, you build. Yes, that one you can say, oh, fine, I don't need a structural engineer because this is just a single building. But when you go beyond a certain type of scope, let's say a story building, you have to rope in the structural engineer so that you can take your safety. You can look at your safety first.
So, say I have an existing structure and I want to do a bit of renovation. What are the key things that I need to consider if I bring you on board?
Okay, it depends on the type of renovation you want to do. Somebody will take a renovation that you will not touch anything, basically. The only thing you do is just the flooring, the windows and stuff, and they are not components to give weight to the building.
Okay.
Unless maybe your renovation is doing, it's going to go beyond the current situation. Then that one, when we come in, we'll be able to assess the building. Either we can add. If we can't add, we have procedures that we can do to increase the building by height.
Okay.
Yes. So when it's beyond the situation, by then we can do the jacketing, the retrofitting. Yes. So with that also, I remember one of projects we did. It was a residence, and the clients got us in to change into banking hall. And banking hall does not need any columns within that will impede the look of the teller and stuff. So they brought us in, and we have to remove the internal columns. So we did our calculations, and we saw that when we remove the internal columns, we'll be able to work it out so that they can have a clear space for the banking hall. Okay. So we introduced the system called goal posting. Yeah, so goal posting is introducing metal into the building as the columns and then the beams to be able to sustain the slab. So when we check the load of the slab, we're able to design the beam that can carry the load of it. So that's what we did, and we removed the columns within, and then the building is functional, and it's a commercial bank. It's working. Wow. Yes. That's so we can do beyond. Structural engineers can do beyond what people are thinking of us. We can do beyond it.
That sounds interesting. Yeah. I mean, how do you collaborate with other professionals, architects, engineers? You mentioned the geoscience guys. How do you do this? Was there areas where you realize that when they're building, the foundation goes a bit deep? What factors do we consider in all these things? And do you work with other professionals in doing that?
Okay, so basically, our profession is not a lonely profession. Yeah, we do that with the architects. Then some of our subsets from civil engineering are the geotech engineers, the water commissions, so the water engineers, the drainage engineers, the road engineers as well. And so basically, it's a six-fold engineering that you have to go through. So basically, when you are doing your foundation, you have to rope in the geotech guys to come and then check the soil. And we have type of soils in Ghana, as you know. So most of our soil too here are very clayey. Yes. So we'll bring in the geotech engineers. He comes to take samples and then do a drill. That's where he'll see his bearing capacity. So he'll take the drill to the lab. The lab guys will be able to see the material that we are meeting, the soil, and what we should do to the soil to be able to stabilize, or maybe we are able to go down to get our bearing capacity. So that's what the geotech guys does. So when they do that, then they have to design the foundation based on the load that we, the structural engineers, will give to them. That's when we've done our work. But they can start also, then we will meet them halfway. Or we can start and give them the load, and then they will design the foundation for us. So that's what the geotech does. So in the building as well, we can rope in the drainage people, that they can come and drain our house very carefully, that we will not have water stagnant in our houses. And then also we can rope in the people who do the roads as well, to be able to help us to do our roads and our roads for us as well. And then I think one of the distinct too is the sewage. We have the people too that does with the sewage, not only sewage, as in solid waste, liquid waste too as well. So they also have to come in. So that's where we get our M&Es, the mechanicals, and then the mechanical engineers. They come in and then they know where water will pass in the building, where we're supposed to do and what we're not supposed to do. Then they were able to take it out. And then also they also design the septic tank, where the number of people within the room or the space can be factored into a calculation. Then they will design the size of the septic tank for you. Then you can use it for a number of years. So when we are designing, we use years. So we say, okay, this house, we have 2 people. How many years can they, be able to use the system so that it can last for them? How many years before they will come and dislodge? Mostly we play around 2 years, and then we design the system to that effect. Then it's so that it shouldn't be like we be in the house and one day, hey, that IMO we should come and dislodge. So we play with that. So the occupants know that within 2 years you have to dislodge, and then you dislodge. That is done by the drainage. The drainage, and then the waste engineers.
Accra, as we know, is mostly clay, and you are likely to find Hits water in most areas. You also have salt in most of the land. How do we deal with it? How do you design structures for these places? Earlier I mentioned that there are areas where the foundation is going deep. Is it because you are going to have a high-rise building, or there are factors that determine how deep a foundation should go?
Okay, there are factors, and let me chip in this. Water is not a friend of engineers, but we like water. Yes. So when we find water, engineers become very alert, because water can cause a lot of issues to our buildings. Yes. So the clay aspect of our land shows that our water tables are very, very high, unless maybe you're on the hill. But when you're in the lowland, and Accra is a lowland area, you can see we have a lot of clay sediments and stuff. So the geotech guys will come and pick the soil sample. Then when they pick it, they know what to do to be able to get to a point at where they need to. And when you do that and you're not able to get, which means you have to do a re-engineering of the soil, so that you can get your capacity. Yes. So there's a form of something we do call dewatering of the site. So you can see, if you look at East Legon like this, some people dig very deep, and then they want to get a good capacity so that they can put their buildings on. So that's one of the things they do. So they go beyond the water table and try to channel the water through other aspects of other channels, so that the water can go, so that they will not have water within the building even as they are going beyond the water table. Yes. So the engineers also have they know how they design it. So, but notwithstanding, with clay lands, we can design our foundation on clay lands. Yes, it's possible. So it's the soil needs to be re-engineered, and also the foundation have to take a form. So we have different type of foundations. We have the isolated foundation, that's the part foundation. We have the combined foundation. We have the raft foundation. Yeah, so each of those foundations have their system of play. So when we talk about isolated foundations, they are the foundations that are mono. They are standing alone in the footing when it's coming up. Yes, they are the isolated. The combined are when we have 2 or more columns at a particular location. Then you do a big foundation for all of the columns in tandem. And then we have the ones that are the raft. So that one, because of the nature of the land, we can mesh the whole system of the bees. When we mesh it, then we know that we will not get too much settlement at a point, because when we mesh it, iron rods work, and then we start our building from there. We've met a situation like that before severally, and we started digging, and the geotech guys came to do their work, and then at a point we saw that the bearing capacity they are giving to us was not what we are meeting, because where they took their samples were a little far at a distance. So we have to remove all the soil at that point, restabilize the land, then we have to mesh the whole ground. And then we are able to put our buildings up there. And it's standing. And it's also a commercial building, and it's working, yeah.
All right. So most areas that are waterlogged, you find out that people are filling with sand. They do that over a period of time, then they come in and then they start digging and start building. Is that something that should be done? I mean, have you noticed that also?
Oh, yes. So if you look at China, Dubai stuff, they have less lands, but they are doing marvelous things. So in Ghana, we have to look at the situation of building in water areas as well.
Okay.
It's not the best, because the water has its own, route that it passes, basically in the soil or over the soil. So when the land is usable, we can still try and do something with the land. We can't say we are going to leave it to the wind or anything.
Okay.
And we can re-engineer the soil, and then we can build, but not withstanding your water problems that you're going to get in future. That's why you have to rope in the structural engineer. The structural engineer will give you if you have to add some chemicals to your mix, so that the concrete or whatever you're going to put down there will become very solid for penetration of water. Then the water can also be at where it is, and your buildings will be very functional.
Earlier you mentioned that you develop your interest from different people around you, your uncle and his friend who you used to trace for. But what are the advancements? I know architects, and you no longer sit down to take pencil and do all these detailed drawings on paper again. There's technology. What is coming up in your space to improve the work that you do?
Okay, so I think technology has helped us very much in that aspect of what we were scared of doing and what we are supposed to do. Because in the old times, I remember our old masons and our old guys, when you build and you want to do a cantilever of just 1.5, they start to shout, no, 1.5 is too much, you have to do just about 600. That's 0.6 of a meter. That's 2 feet. But now, advancement has come to the point of where we are using AutoCAD, Prota, and then the steel works. How do you call it? Prota steel. You have ETAPS. You have a lot of structural element. Softwares that are coming now, and making our work much more easier, and making us to do beyond.
Okay.
Yes. At first, we can't do whatever we are doing now. And now you can see much buildings are having bigger space areas that you have column apart, and it's still functional. Yeah, so I think technology has helped us very well to be able to do a lot of things. Yeah.
That's great.
And let me chip in this. The board too was very interesting. Yeah. It was very interesting.
Okay.
Yeah, because it teaches you coordination, how you coordinate your left hand to your right hand.
Okay.
Yes, and how you move your T-square by the table, how you use your right hand to do the drafting, and even how to write.
Okay.
It have a unique way of writing. So when you do that, your work becomes neat.
It builds your experience.
Yes, it builds your experience. Yes, that's the word. Yeah.
Right. So how do we incorporate sustainability and energy efficiency into our buildings? What role do you play in that? Okay,
so sustainability first comes from the understanding of how you can keep your building for a longer time. And one, the material. So the material you are using, is this sustainable in the system?
Okay.
That maybe when it gets finished, will I get another? You understand? Okay. So that's where you look at maybe the sand. We have it in abundance, so we can sustain.
Okay.
Yeah, we have stone in abundance because that's what we are using for our system now. That's the concrete coats that we are using. Yeah, so it's much more available. That's why we are using. But I think at the point of unavailability, we can say that because it's not available, we are going to use other materials in our building situations.
Okay.
But because we have the sandstone, we are sustainable, with it.
Okay.
But people are doing more research by coming out with using the hydroform. Yeah. And it's also sustainable because we have clay in the system. Okay. The clay too can come and help us in the filling in, doing our blocks and filling in our partitions as well. Yeah. And then looking at the serviceability aspect, it looks at how you are going to sustain the building as you are living in it. So maybe how is it going to keep long for me?
Okay.
And when some point of it gets damaged, how am I going to replace? So it comes with sustainability, serviceability. So the two, how am I going to push them together? Serviceability and sustainability. Yeah. So I'm living in maybe this space, 1 meter square area space or 2 meter square area space. How am I going to, repair a place when it's worn off?
Okay.
Is it just painting? Is it just plastering? Yeah, so you have to come into that aspect as well. So when the civil engineer comes into that, it will give you a point of, I have this much, so when it happens, I can use it. Yes, and it will even boil down to your costing as well. You not spend too much money importing things into the country and saying that, because this is made by this and I have to import. You understand? So it's within, and then you can easily access it.
So what are some of the challenges you face? The last time I spoke with an architect, she said, because she is a female, initially when she started, the men find it difficult taking instructions from them and all that. For you, what are the challenges that you face when you go into the field? And the masons who feel they've done this work for like decades, and they have, we can do it like this. How do you deal with such issues?
It's true. Older people always comes at a point of they know it all. Yeah, because you are too young and you are coming to the space. They think they've done too many works that you have not even done. So they try to shove you off. But with that, always for me, I always tell them they are the best on site. But not saying that because they are the best, but you have to encourage them to able to accept you. So when they accept you, they also accept what you bring on board. Yes. So I think the lady architect shouldn't be discouraged with that. She should make them accept her. And then when she's able to, implement ideas and they see that the idea works, they always will salute at that point.
Yeah, I think she's actually gone beyond it. She's done over a decade now, so that was the early ages. The building sector, like the real estate industry here in Ghana, it's booming. Almost everybody's putting money into real estate. Would you say they approach you when the problem is already there, they've encountered a problem, or both of them come from the beginning and are individuals doing same, or you have to find more of the people who are running corporate business or running real estate companies are the ones who say, okay, we need to use a structural engineer from the beginning, or individuals also have that knowledge and know that, okay, we need to bring in this professional. You're not just a draftsman or just an architect, and once I have my design, I'm good to go. Or they get to the assembly before they know that, okay, I need to get the drawings from a structural engineer as well.
I think our education level of these things is very poor. And then a lot of them, I will not call them novice, people who don't have the idea in what they should do and what not to do. They always listen to the people on the field. So the people on the field give them the way they should go. And basically, they even overlook the architects, overlook the structural engineer, and then move to a mason and tell you, I have this plot somewhere, come and see what you do for me. And so at that point, when the mason or mason sees is beyond him, then he will tell you, I have a friend, an architect, bring him on, and then you come and do. So I think it's the education. Mm-hmm. The knowledge is not too broadened for the people to understand that what we have to do and what we are not supposed to do. Because when they are coming to, the idea they have is we are coming to charge them, forgetting that we are charging them and giving them safety. Yes. So now I think things are shifting a little by the moment, because people are getting a little bit enlightened on bringing on the architect and then the structural engineer in, so that their building can stand the test of time.
Wow. That for me, so again, because I have seen, I've worked around an architect, usually you realize that when they have an issue, then they call you. You come in from the beginning, everybody thinks that everything is all right until the problem comes in, or they've gotten to a stage where they want to change the design of the building, and even though you have columns, you're on the next floor and you think you want to change the design of the building. And that leads me to my next question. So I'm building a story building, it has a plan, like we're recommending that because you want to save space, would want people to have plans that go into the future where I can do the first floor, ground floor, and then next generation can come and continue. If I do that and the next generation comes and want to do maybe a different design, still continue but do a different design, is that also doable?
It's doable, because if the concept stays the same, everything is the same.
Okay.
It's just maybe a partition design that will change.
Okay.
But the concept is still the same.
Okay.
Yeah. And basically, it's maths. 1 + 1 is always 2.
Okay.
Yes. So when your 1 + 1 that is coming on is still 2 and it's not 3,
Okay.
it should still stand.
All right. I mean, it's been great having a conversation with you.
You.
And looking at how our housing deficit, the last time I checked, I think it was 1.8 million housing deficit for Ghana alone. And if you go across Africa, the number actually goes up. What would you say one should consider if they want to build or move into the real estate space? What should they consider to ensure that, one, they're ensuring safety, they are saving costs, the buildings will be sustainable, and the serviceability or making sure that it fits for purpose is achieved? What should one consider?
Okay, so basically, when you buy the land from the chiefs, some of them will be clear enough to tell you that this land is for commercial or is for residence. Yeah, so you should be able to know that. That's the first thing you have to do. Second, you have to make a search on the land. If the land is maybe it's not for maybe inhabitants, for animals or anything that they've kept for history's sake. Yeah. And then also, if nobody have registered the land, because as you are buying the land, it's a lot of money. Mm-hmm. So you have to be able to know the purpose of the land, the ownership of the land, and then from there you can rope in your other artisans to it. Mm-hmm. So with that, when you get your documents, you go to the land survey to do your the check. That's what we call it. We call it a check. Okay. So when you go there, they will check your land for you to see whose name is there. And when you know that the name of the person who is selling the land for you is who is there, you can accept, and then you can do your. But firstly, don't do your payments. You have to check the land first before you can do your payments. With that, he will also give you his documents by the check that you've made, and then the chiefs have to sign. Don't forget that. The chiefs have to sign your documents. If not so, they can return. Yes. When the chief signs the document and somebody comes, the chiefs have sold it to me and stuff, that one can get the litigation aspect to court, and then you can get either your money back or replacement. So after you get your land, then you you call in your architect to come. So you can even resurvey the land as well, to know the size they are giving to you is the same. If it's the same, your architect can come in, and then you tell your architect what you want by your planning. Then your architect can also lead you through the aspect of building.
All right. So if there's anyone out there, ATTC wants to, or in a technical school wants to pursue structural engineering, what will be your advice to them?
Wow. Okay, so structural engineering is architecture and structural engineering, they are science-based.
Okay.
Yeah, so it's very difficult in Ghana for you to rope in yourself to that aspect of technical and doing science.
Okay.
Unless maybe you are you want to pursue a little higher. Yeah, so from ATTC or maybe from the drafting or from any other lower this thing, you can't even enter into the university because of how our system is. You have to get a science base to be able to do architecture or structures. Yeah. So for somebody like that who wants to do architecture or structures, the person have to keep learning and have to go and work on the science and maths.
Okay.
With that, when you have good grades, the university can take you. Then you can, further your course from there.
Right. Yeah. When you say science and maths, are you looking at physics?
Yeah. So the course, the electives, sorry.
The electives.
The electives.
Okay, so your elective maths, your physics, your chemistry. In some cases, they do geography.
Yeah.
Okay.
Yeah.
Biology is out.
And you have to be good at that. If not, so the university will not take you.
All right. All right. So, Lela, all too soon, I'll say that it's been a pleasure having you on the show.
Thank you.
Thank you very much for coming, and we look forward to working together in the future.
Thank you.
Thank you for coming on. All right. Enjoy the rest of the year.
Thank you.